Hey everybody. So quiz tomorrow, all right? I'm going over the practice quiz with you now so that you can be ready for the quiz tomorrow. And no, I won't be here. I won't be back until Friday, and I don't want to make you guys take the test on Friday. I want to do something fun instead. So when moving from exponential to radical form, explain what to do with the numerator and the denominator of the exponent. Ready? Here's what you do. If you have the rule was if you have a and m over n, you can go backwards and forwards too. Ready? A to the m with the n as the root. So what you do is you put the numerator inside and you put the denominator outside. And I'm going to remind you as a root. And we are taking the root there. So when I rewrite this one in exponential form, what I will get is k to the 7 over 5. Now notice that the parentheses are on the outside and the 7's on the outside. That doesn't bother me. It's not a problem. It shouldn't be a problem for you either, okay? Write each expression in radical form. Here we go. I want to take the square root of 6x. Now technically there is a hidden invisible 1 right here. And there's a hidden invisible 2 right there, but I don't really like writing those things down. I like for those to be hidden. So again, I'll just say this is the square root of 6x. All right, now looking at all these problems, I'm going to do a video that I'm doing all the evens, and you're supposed to do all the odds. So I want you to be practicing today and trying your best to get those done so you can be ready for the quiz tomorrow. The square root of 45 is the same thing as 3 times 3 times 5, and yeah, I've done this in class. A couple of your classes, you guys have seen this one. I'm sorry. I'll do the other one instead. Here we go. So negative 3 times the square root of 5 is out there. There is another negative 3, and there is another positive 3 this time with the square root of 5. So what I did was I transformed this into that, and I'm substituting it right here. So I have negative 3 and out in front, and that's the square root of 5. Hey, these match now. Yay. So that means that I can actually combine like terms out here. Negative 3 times the square root of 5. Multiplying negative 3 times negative 3 is negative 9. I have negative 9 times the square root of 5. I am going to be able to, ready? Give you 3 square roots of 5. Give you another 9 square roots of 5. I have given you 12 square roots of 5. That's how I like to think about negative numbers, remember? Okay, so I did that one. In the interest of being fair here, I know I haven't done problem number 7 in any of the classes. And all 4 of these are adding and subtracting. So they all have the same basic process to them. So let me look at the square root of 12. I'm going to say that that is 4 times 3, which is 2 times 2 times 3. Getting married and leaving the radical house. So I'm going to say that I have, really, this is equal to 2 times the square root of 3. I have a 2 times the square root of 3 out in front, which is interesting. It means somebody probably simplified the square root of 12 for me already. And then I have a 2 times another 2 times the square root of 3. Think about it, it's like the problem has already been half done for you. I simplified this into a 2 times the square root of 3, and I'm substituting it right there. But somebody already did that here. All right, so I'm going to say then that I have 2 times the square root of 3 plus these guys should be multiplied together. 2 times 2 is 4 times the square root of 3. And I'm going to say 2 plus 4 is 6 times the square root of 3. And that's my answer for that. So all of those are adding and subtracting. And then the next two, these guys, 8 and 9, those are multiplying. And on your notes, you might want to remind yourself to put them into a single radical first. So I would say that I have the square root of 3 times the square root of 12, and there's a minus sign. So out in front, I'm going to bring that hidden invisible negative 1. And then inside here, I'm going to say I have that 3. And then what numbers make up a 12? I think it's 3 times 4. So I'm going to say I have 3 times 2 times 2. Getting married and leaving the radical house. Getting married and leaving the radical house. I'm going to end up with negative, 3 times 2 is negative 6. Now, number 9, I want you to try it. I will show you the answers to the worksheet at the end, okay? So at the end of this video, you can see all of the answers, but you do need to show work to get credit. All right, I'm going to do number 11 because I'm pretty sure I did number 12 in a bunch of classes. So looking at this, I have division going on. In fact, all 4 of these are division. But honestly, these last 2 need rationalizing. So first thing I would say is that I think about it as if this was just 12 over 100. And if this was 12 over 100, I'm pretty sure that both of those numbers are divisible by 4. So I'm going to divide by 4, and I'm going to see what I get. 12 divided by 4 is 3. There's a square root of 3. That looks pretty simple. And I have 100 divided by 4, which is 25, which as soon as I write that square root symbol down, I realize is just 5. So my answer is the square root of 3 times 5, because remember, you're not allowed to leave a radical in the denominator, but I'm good here. I don't have a radical in the denominator. So I'm all done. All right, let's try 2/3 then. If I want to rationalize, it means that you multiply by, ready, I've already done 12 for some of the classes, so I'm going to do number 13. I'm going to say then that 3 over 6 is the same thing as 1/2. So I have the square root of 1, and I have the square root of 2. And the square root of 1 I know is 1, but when I see that there's a square root in the denominator, this is bad, I have to rationalize it. I'm going to rationalize it by multiplying by the denominator, something that is equivalent to 1. So I'm not actually changing the value of the fraction, I'm just making it look better. 1 times the square root of 2 is the square root of 2. 2 times the square root of 2 is the square root of 4, which is 2. And that is my final answer. Kind of an ugly looking square root, but there you go. Okay, now for the last ones, I will say, I'm sorry if you didn't know this. I found out later on in the day there is a typo on the worksheet, so please change that to a 2000. Okay, that's what I expected that to be, and I say that because I wanted there to be something that you could take the 4th root of. And so the number that I gave you over there, 3000, there wasn't anything, but here if I do 2000, let's see, I can divide by 2 and get 1,000. I can divide by 2 and get 500. I can divide by 2 and get 250. I can divide by 2 and I can get 125. And you see that there's 4 2's in there now? 125, let's see, I can divide that by 5 and get 25. I can divide that by 5 and get get 5. And I'm bringing that last 5 over. There's only 4 2's in here. There's not 4 5's. So my answer will have all of my 5's still inside of the radical. Here, I'll show you. This is 2 times 2 times 2 times 2, and this is 5 times 5 times 5. But not just that, I had 7 x's, 1, 2, 3, 4, 5, 6, 7, and I had 5 y's, 1, 2, 3, 4, and 5. Getting married and leaving the radical house. Getting married and leaving the radical house. Getting married and leaving the radical house. And inside of that 4th root, hold on a second, let me make that look better. That 4th root, I still have the 125, which is all 3 of these 5's. I also have an x cubed, and I still have a y. And that, my friends, is the extra credit. Good luck.